So next month, Juan, Manef, and I will have a new one. But this meeting, I wanted to rehash one that we did a while ago because it came up on 3 or 4 projects of mine in a row as an issue, and it's something that we have to catch early. So in situations where we have a frame where it's being dead loaded at multiple different floor lines, those floor lines can move independently under live load deflection. So if the second floor line deflects down, say 1/2 inch, but the bottom floor line doesn't, we could have some racking in these DLOs if it's a single. And to avoid any kind of racking like that, we'll need to add a double mullion with a sealant joint between, kind of acting as 2 separate jambs separating the frame from each other.
Sometimes they call that a dummy mullion.
Yeah, and a good way to do it where you can hide it is you could have one of those be an SSG mullion behind the glass. So from the outside, it looks like the single mullion going full height like they want. But then the other side has a mullion, but you can't see it. But this is something that you want to catch early because it does change the look a little bit. And if you catch it late down the line, it can cause major heartaches. And luckily, in the ones I've had recently. But I also wanted to go over a couple of, I guess, examples of. So do we need a double mullion here?
No.
No. What about this really tall frame? So we have a lot of these strip curtain walls spanning multiple frames up. And then it's shorter areas where it's just the top. Do we need double mullions between those?
I think it's a trick question. I'm missing.
Are we tying it to a structure behind it, like a floor line, or just like a window?
Well, this is a different sheet, but it shows it a little closer. So we have these, we'll call them wind load clips. I think they were dead load clips. We'll say they're wind load clips for this example. Do we need loads or double mullions between the tall and the short sections?
No.
Yes.
Why do you say yes?
Because they have different racing at different locations, so that's like different.
That's not a pass. That's just like a student's horizontal.
Is that the horizontal?
Is that horizontal shift up in any way below it?
No, it's just joint below it.
That's the reason I'm going to say you don't need it, because it's all going to grow together.
Yeah, it just acts as horizontal.
What's the thermal expansion on it?
So it is actually dead load here. It has an expansion joint below that dead load.
I was gonna say
It's all wind loaded.
that what you had said about expansion and why I asked about thermal is because what about contraction? If your expansion and contractions.
Right, but you can take that into account with
Right. You just need to pay attention to.
Still designing the joint.
You just have to design the joint below this horizontal.
But I'm not concerned about racking, which is typically why we have a double mullion.
Yes, it wouldn't be.
That makes sense.
This one's a little funky. So what we have going on here is this is one frame. It turns a corner at this top section to
In the middle of a DLO? Oh boy, Kevin, sorry about this project.
It's mine.
yeah. And this is the other side of that corner. So this has more than just racking issues. But what we ended up doing with this one, luckily this was in prelim. So we had a little bit more flexibility of how to fix this. One of the options we sent to MP and they liked and they sent over to their client was changing this. This is a corner mullion, changing it to a built out corner and having this jam extend all the way out with the built out corner at that jam. So it just turns the corner at the built out. And then
Like a two-part like box.
yes, yes. So the jam goes all the way up, but the top has the brake metal jam on the other side. And that's how we ended up solving this. But do you see any other issues with how they tried to do this?
Yeah.
Getting more and more complicated. Watch out for these.
I do not like non.
I've had a few of
glass.
these on MP jobs specifically.
How do they connect, how are you connecting all that?
I think what
Especially
they
if that's
expect, yeah, I
all
think
of
what
the-
they expected, it wouldn't work anyway, so I didn't really dig too deep into it. But what they expected, I think, was the small little horizontal jut right there to the bottom vertical to come in and have a shear block connection. to
Oh,
that
not like a
little-
mitered corner.
Yeah,
I would be so worried about the stretch risers and that glass,
Yeah.
that little 90-degree corner.
yeah, we thought about like trying to do some sort of HSS tube that goes all like is welded, all like zigzag weld, but then that puts some torque on
Yeah.
the lower mullion. Didn't like that. But that was my last weird example that I had.
And watch out for those jogs because they've been putting them in.
Yeah.
It's like a mind warp if it's stable or not. Like, okay, so here's a question. Let's say that jogged horizontal extends over to the next vertical over. Is that okay?
If it's like
Just is it
Oh,
stable?
in other
it
words,
goes
that's a great big
this way.
piece of L-shaped glass.
So the glass is
Like-
an L shape that's two pieces, they cut it into two pieces of glass.
like
They
if
run-
this is
Oh, okay, the horizontal goes all the way over there.
Uh-huh.
Yeah, you're gonna be
It should
jumping
be
a lot.
stable if that horizontal, if it's running from the corner all the way over.
Where are anchor points at? Let's ask that. Where are anchor points at, Kevin?
So we have these wind load clips
Okay.
right below.
So you just have to make sure you detail it really well, but yeah, it's stable. It's just like a mind.
Well, it's like,
Yeah.
That was one of the things that we told them they could do, but I mean, that doesn't solve the racking issue. It's the other problem.
How do you, so how big was the joint between that vertical and the little step out? Was there like a silicone joint there on your shear block?
It's probably nothing yet.
Yeah, they didn't prelim, so they didn't really have a detail for it.
Yeah.
Yeah.
Because I always wonder, like, yeah, if you have a vertical, then they're gonna shear block that to the bottom of that horizontal. Do we need to account for thermal expansion of those bottom two lights plus some change for that vertical to grow into it?
Trick with that, if you do that, then you introduce the issue for the lessons learned, right? So like, if you do that, you need to put an expansion joint across the whole frame. Otherwise, you've got racking from that vertical over. So you'd have to do, the only way that we have done this on a few of them, and it is weird, but you'd have to bring that top, the corner vertical would have to come down, sit on top of the horizontal. And then your horizontal would run across, and it would essentially be cantilever. So the lower vertical would come up, shear block under the horizontal, and you'd essentially have that horizontal kind of attached to the vertical to the left, and then come out and cantilever over to pick up the corner. And then you've just got like a weird splice, a hard splice.
Yeah.
You've got
Yeah.
a unique hard splice that you've got to, and then you've got to run that hard splice out across the frame and check to make sure all those shear blocks can take shear.
So in
Releasing them
RISA,
off.
you would model them as a fixed, like you wouldn't release the ends of that little horizontal. Is that how you would get your loads to check it?
I'd release it, and then I'd release my verticals tying into it, And then Reese is a good check on if you're being crazy and it's not stable,
Yeah.
you know? So
Yeah.
Here's another thing. So how tall is it to that little jut?
They have it. Oh. Forgot my mouse. So do it.
So another thing that.
Well,
20 foot.
Yeah.
And we need to pay attention to it now. I don't think we have if it's this much, we call it good. If it's not, I think it's case by case basis. We make the judgment call. Is that if you have an 1/8 inch of thermal, are we really concerned? Are we really going to put in a double vertical in something like that, an 1/8 inch for racking?
I think it kind of depends on how narrow your DLOs are.
Yeah, I mean, there are a bunch of things you need to consider.
I always try, like even like over 10 foot. I know like sometimes we're liberal with it or whatever. I'm like, I always at least try. And if they fight back, then I dig in. Is there a corner there or is there a column there?
Yeah.
Is there enough racking to cause concern?
Because in my previous projects, I've done like all shapes, small shapes like this, any angle you can see for this glass. So what I've done is like I'm fixing. I'm not releasing. Like these joints have like moments. So in return, you have like a big connection inside, like 10 screws, 12 screws, 16 screws. So you make a fixed connection. I've not seen that here, but have we done that?
It's
Yeah.
the
Systems
thing is,
can't handle
it's that clients probably are gonna, we talked about like, yep, great ideas, this would solve the
Yeah.
issue. They're not.
Architects hate the look of screws.
We go
A
to
lot
that
more visible, yeah.
dire emergencies, like
Uh-huh.
if they're out on site and this didn't get caught.
Or if you have like a 36-foot span, no intermediate
Mhm.
connections, you have to do something like
Yeah.
that.
Yeah.
Yeah.
Yeah, good one.
Nice job.
That tiny building.
Nice job. It's
Kevin, one
no, not on this.
okay.
one
You got
last
it.
question,
Well,
Kevin. That I
I'll have one
wonder.
next.
I wonder if this was discussed on this one. The risk of tearing any IGU sealants, secondary sealants, was that discussed with the client and say, hey, on this little corner, how are we making sure that the IGU doesn't like start tearing sealants like
By being
secondary
twisted.
Yeah, the way
Yeah.
we fixed it, it ended up getting rid of that tiny little corner. Because we ended up running this jam all the way up. And being essentially a jam the full height
Yeah.
instead of turning the corner like that.
Yeah.
So we didn't have that discussion because it didn't end
Okay.
up happening.
Yeah, I mean, that would end up getting ugly if you need to like figure that out.
Yeah.
I have one last, I guess, 'cause that's a good question. So anybody working prelim, and we've kind of done this with osmosis when we're working some of the MP drafting jobs together, but don't be afraid to make your job easier and just at least throw out, like Kevin's saying, like if you see something weird, that's the best part about the prelim. If you see something weird and they drew it weird, don't feel bad about, because usually our motive is like, oh, I got to figure out how to do this. Don't feel bad about like, hey, can we just make this easy and run this vertical here? They might not have thought about it and they run it by the architect. Like, oh yeah, that's better for waterproofing.
Yeah.
Better to install. We don't have to do this crazy. So don't feel weird about that.
Talk to them first.
Yes.
Yeah.
Before you,
Yeah.
before you
Yes.
Run a quick sketch by
So,
them or send it by
yeah.
the team.
It's funny because I feel that sometimes we, especially newer engineers that are getting into the industry and getting more confident as time goes by, it's a fine balance between let's stick to what is shown on the drawings, but what Matt, to Gorney's point, we don't want to forget that we are the experts in the industry for this and that they're coming to us for consulting on this like delegated design thing. So we've seen likely we've seen more of that detail or of that specific case than the architect or the GC have seen, because they're coming to us because we are the experts. So to Gordon's point, yeah, we don't shy away from giving our expert opinions. Like, maybe we can do this cheaper, better, more, to resist the wind better, But again, like you were saying, of course, there might be many things behind the scenes that have led to them making the decision of making or showing something on the drawings. So of course, it's always encouraged to tell the client, hey, we think this is better. Is there any problem doing this? So mixing that with our confidence to be the experts on this. So
Yeah, good point.
Yeah.
Something, let's say 100+ foot curtain wall run, that's probably a conversation that needs to be brought up as, hey, we need to talk, we want to let you know thermal expansion along the length of this could play a factor in the longevity of the curtain wall and during installation.
Yeah.
Let's talk to the manufacturer, get their opinion. We may want to consider adding
You have to do a double.
a double with a,
You can always do that, in very, very long runs of curtain wall. You can possibly bring that up as an option to the client and see if they want to buy off on it. Another thing to watch out for is whenever you see expansion joints in the structure, don't cover those up and run past those expansion joints in the structure, because we'll be in a real mess. That we have to reflect the expansion joints in a structure that's very long, and we have to have those in the curtain wall system as well.
does that include masonry joints?
Those are movement joints more than expansion joints, and so no, it doesn't. And so it's the major joints that are usually 2 to 3 inches. They've got a kind of a rubber gasket.
I have kind of a related question to the tying together of verticals at the horizontals. So we're assuming that they'll typically leave like a small gap with the horizontals and they won't be mechanically fastened to like the verticals. Then does that mean that for corner mullions, we shouldn't be relying on adjacent verticals for bending out of line?
They do attach.
Yeah.
Yeah, that's a mechanical.
I'm hesitant to.
You're talking about where the horizontal comes into the vertical.
Yeah, so like when a corner mullion like bends out of plane, we'll often rely on the horizontals to like, rely on the IY of the adjacent verticals to like restrain.
There's still
lateral
a
movement.
mechanical connection.
There's a couple little screws.
Yeah, there's screws. It's not.
So it's like a weird, that's why I say like we just don't think about that one. Because there's two countersunk screws into the face.
Right.
That you think, okay, well, can that take thermal expansion? I guess it's oversized, but it's
That's not necessarily just at a corner. You see shear block connections, they screw in through the front. It's the same thing.
Right.
So
and that's
if it can take thermal, can it take load? Because
Can it transfer
because of the
load
connection.
to the,
That's
so in other words, if it's so loose that it can take thermal, why are we transferring load, down a line of verticals at the?
Yeah.
Well, wouldn't it be because
You be quiet.
I'm sorry. I've never brought up, and since it's been an issue in the field, I don't know. I think it's
in a situation like that, if corner's deflecting, it's going to deflect more than a 32nd of an inch. It will engage, and it's a short engagement.
Yeah.